Okay, here we are, Stats and Mechanics Year 1, Chapter 10, Mixed Exercise, Challenge Question. If you haven't done question 15 yet, it's huge, okay? But the challenge question, I hope, might be easier. Okay, in this question, I and J are unit vectors, east and north respectively, okay? Two boats start from rest at different points on the south bank of a river. Okay, so one river, two boats, south bank. Let's see what happens. The current of the river provides a constant force of magnitude 3I. Okay, 3I is coming through here on the river. The motor on boat A provides a thrust of 7I2J and the motor on B provides KI plus J. Given that the boats are accelerated in perpendicular directions, find the value of K. Okay, two boats start from rest at different points on the south bank of the river, the current in the river. So this one is going with, this starts here and it's got minus 7I and it's got 2J. And this one is doing K I and plus J. So it's got J and it's got Ki. In fact, that way, isn't it? Doesn't really matter. Okay, they haven't distinguished it. Given that the boats are accelerating in perpendicular directions, find the value of K. Okay, so we can work out what boat A is doing, okay, because we can put together its forces. So its forces there are going to be, let's do it as the 3I is coming in against it. So we've got 3I and 0, and that's being added onto the minus 7I and 2J, like that. Okay, don't need the I on there. So the resolution of the forces on boat A, like that, will be 4, 2. Okay, so they will be, that will equal minus 4 and 2. Okay, which is minus 4I plus 2J. Okay, so it will look something like going minus 4 this way and then plus 2 this way, meaning it's going out in this sort of direction. Okay, and that's the direction it will be accelerating. It's given a force going there, so it will be accelerating along. Okay, the motor on boat A provides this, the motor on B provides this. Given that the boats are accelerating in a perpendicular direction, okay, so that means that this boat here, this B boat, must be coming out of here at 90 degrees to this acceleration. So whatever K and J is, okay, not J, but that's 1, isn't it? Because it's a singular unit. K1 is, okay, when it's added onto something, there we're going to have the line of it, okay, because we've got the direction of that ultimate force, which gives us the direction of the acceleration. So the perpendicular one is going to be 4, 2. Now it's not 4, 2. It's got to be, is it 4 up 2? Let's just have a look at that. It's 4 this way and 2 this way, which looks like that. So when you do it at 90 degrees, it's 2 this way and 4 that way. So that's across 2 and up 4, like that. Okay, so to bring that down to 1 with the k, we're going to need to say divide by 4, which will then give us the 2 over 4, which is a half over 1. But I haven't considered yet on there the 3i. I just completely ignored it. There's still the river on there. Let's do it again, taking into account the fact that I want it to also be adding on to 3, 0 for the force of the river, and that will equal my 2, 4. So when we do that, we end up with 3 plus k over 1 is equal to 2, 4. Okay, don't know where that came from. And so when we start looking at that, we want to make it 4 times bigger. So if I multiply this or divide that by 4, okay, so now I'll do my divide by 4 on there. So I'll get 3 plus k, not over, it's not a fraction, 1 is equal to a half over 1. Now we've got these things correct, I can write 3 plus k equals a half and solve for that. So k equals a half minus 3, k equals 0.5 minus 3 minus 5 over 2. Okay.